So what we want to do this morning really is to talk a bit more about Material Studio, and in particular to the recent development that were performed for done into MS 6.1. I assume that you have installed up and running MS 6.1. We will do this, so this morning we're going to have lots of talks, and then this afternoon we'll do some workshop. And I will divide you in two groups, in beginners and advanced. And it's really for, so who has not used Material Studio here? Okay, so maybe we have 3 beginners. The material, some of it can be downloaded from this FTP site. Any question, ask Jarek. And otherwise we have printout for the advanced, which I suspected more of you would have known Material Studio by now. Oops. That's for later. So my name is Marc Meunier. Bye. Any one of you I've met? I come here every year, almost, except last year, and always get confused by the different location we have this meeting in. This is an ELN, by the way, but that's not my talk for now. So yes, I am based in Cambridge, UK. You can hear the strong English accent, right? And I've been with Axelis for over a dozen years now. I work mostly in material science, chemistry. My background is a PhD in chemistry, postdoc at Imperial College, London. I worked a lot on electron trapping, and I will talk a little bit about nanodielectric later on from my latest conference talks. So, Material Studio, so for those 3 beginners, what it is, it's a software package allowing you to sketch models, to apply various computational techniques to those models, and get in output some properties, chemical or physical properties of importance. So relevant to different, say, chemical reactions, important in catalysis, important for looking at the behavior of polymers, and rheologic properties or mechanical elastical properties, diffusion, important in electronics, optical, magnetics. So we have a various set of tools within Material Studio, and that's one of the very strong points of the package, is that it allows you to sketch very many different type of models, as you know, of crystals, periodics, or bulkables, and so forth, and then apply sets of techniques, so quantum mechanical techniques, where you use the CASTEP, the D-ball, and then the molecular dynamics, Newtonian-based forces, the method, sorry, and mesoscale for the polymer architectures and structural properties, and morphology and phase separation and things like that. So you have a very good interface to build lots of various objects, a lot of different models, representing real materials, and then a lot of different techniques that you can have, all that in the single package. So, as I said, you can apply that to polymer formulations, so look at the morphology, the separation of your systems. You can look at mechanical properties in catalysis, so that's very important. That's probably the main applications of those tools is in prediction of reaction rates, kinetics on surfaces, adsorptions, catalysis sites. A bit less known, but very strong set of tools in Material Studio as well is everything about crystallization. And the software, however, called Material Studio, is also used a lot in pharmaceutical science for crystal structure prediction, polymorphism, morphology, and say also chemical, physical property like solubility and so forth, and glass transition temperature, say, of an active. What they do, mixing energies of the drug in formulation. So that's also very important to them. So that there's a lot of tools for crystal structure prediction and polymorphism, and analytical instrument simulation, like simulating an X-ray or NMR and UV. We'll see we have many techniques within the package to represent spectral properties. So IR, UV, NMR, core level spectra, yields, and so forth. So really, so for 6.1, really making a material impact on business. So the first important achievement in this 6.1 release was about connection between the various software of Axeleris and plugging Material Studio in the Pipeline Pilot interface, and to be able to call Material Studio from the platform and vice versa. From the platform you also have the Material Studio collection to call upon the technique within Material Studio. So that was one. Second one was also about performance and large-scale calculations. Something very relevant here because you have access to the ICM supercomputers, and with all the token and licenses that you have, you may be able to distribute a lot of very large simulations, and we made them even faster. And then DFTB plus, so that's type binding density functional theory, and that is an important tool that we are now working really hard on. And in this 6.1 release, that's already the second release of the DFTB plus module. In that particular version, we have improved the libraries that you can use. You know, DFTB plus uses some sort of semi-empirical parameters called library, SKF libraries, that you must use to perform your calculation. So basically, that gives you the possibility to run very fast quantum mechanical based calculations. So it's very good to have some good accuracy on very large systems, and it's well parallelized. And so I will talk a little bit more about that. And then in the training this afternoon, we have, or is it tomorrow morning? Maybe this afternoon. We have a tutorial on how to develop your own parameter for DFTB+, how to improve an existing library, incorporate parameters within a library. Obviously, we have published a certain number of libraries that comes within the software, but it's important sometimes you have some new type of bonding or new element or something, and so you can just add a new element to that library, assuming you do all the calculations. So we'll see how to do that. Tomorrow morning. Everybody's coming to the training tomorrow? Who is not coming to the training? Okay.
I'm so sorry.
You must be. So the visualizer, so most of you know about MathStudio. As I said, one of the very strong point of the interface is the ease to build very complex models. And one can say, well, we're using Axeleris software, we're paying all this money for some tools I can use from a Linux platform. Well, you know how difficult it is to build very complex models. And if you want to build, of course, you can import CCDC data, but if you want to import and you want to build very complex materials and simulate real materials and have a lot of different elements, then Material Studio really helps you to very easily build those models and save you a lot of time. That's an important point here. It saves you a lot of times by having a model that not spending a lot of time finding out how to do all the Cartesian coordinates. That might be some fun to find out how to cleave material, to cleave a surface and so forth. But really what you want to do is to apply heavy quantum mechanical, say, methods to your models, not so much building them. So you also have a possibility to automate tasks. So we have two things here now. You have a scripting API, so that's a user interface to write scripts, so Perl script, Perl based. And also now with this 6.1 release, you have the possibility to connect to the Pipeline platform, which I will talk about after. Of course, not only you can build all those models, but you can also retrieve all the data back from your heavy calculations and analyze those results very easily, again, by having a way to plot molecular orbitals, middle planes, hydrogen bond network, and so forth. So that is very important as well. It saves you a lot of effort not to have to write all the subroutine to do the analysis of the data you are eventually after. So many different tools in Material Studio, and if I look first at the one based on quantum mechanicals, I have CASTEP. So who's using what here in the users? What were you? Are you using any of the QM tools? Are you a beginner? No. Oops, that went back.
We use CASTEP. We use 3 of us.
Yeah. So DMOL. Yeah. Anyone else use DMOL? CASTEP? No? Are you classical? Polymer? Pardon me?
Just a beginner.
Just beginner, yeah. No? Okay. So we have plane wave code CASTEP for electronic properties of solids. DMOL, as you know, for solid or molecular. Very good for chemical reactions. OneTech will play a bit tomorrow. Order N time bending, electronic methods. That's for very large scale QM tool, Gaussian interface, and then we have hybrids, QMira, which is DMOL plus Sculp. That's a QM-MM method. And then we have semi-empirical like VAMP, MOPAC-like, and DFTB plus, right? Which we will talk again a bit more. So with CASTEP in 6.1, I'm just talking about the new thing here. For example, an improvement was to specify the frequency range, because if you have a big, say a solid, you might not want to do the entire spectrum. You might be interested in only a certain range. And however, so users said, well, that's a bit too expensive to calculate everything, and Raman calculations are quite heavy. So here we introduce the possibility to specify a frequency range and then just have that. We also corrected calculation for slabs. So if you have a dipole in a slab, so before you had an error, you had to correct, so that is now implemented. Addition of the HSE functional, I will talk a little bit about that after, and more parameters for the dispersion correction, the DFTD. D stands for the dispersion correction in the Tischenko-Schulfer method, which in CASTEP also in DMOL. So if I look at the HSE 3 and HSE 6, really, the improvement of those functionals are on bond gap prediction for semiconductors. That's really the main. So if you look at your materials, the bond structures, and you look at your gap, so the typical PBE functional gives you a marginal underestimation of your experimental, about 0.8, and whereas your HSE, I think it's a 6 here, give you pretty much spot on bond gap. So there is a correction. It's not a Caesar operator, it's a new functional. So, oops. So we have this HSE functional. So DFTB came out in 6.0, that's a new module coming out of the Nanotechnology Consortium originally. So support molecular and periodic models. And non-periodic systems. You can do single point energy calculation, optimization, and dynamic as well. So you have all the analysis from the trajectory. It basically uses the Foresight Plus engine and the Math Server engine to do all the analysis of the simulations. And you have this also this parameterization task in 6.1, so you can automatically generate new parameters. We'll see how to do that in the morning. And then it comes with some libraries, and we'll have actually some more. And then what you get out, the usual quantum package. So if you use a DMOL, so you get density, bond structure, dose, orbitals, population, and so forth. Huh? And you can also do the dynamics and see a reaction. So in 6.1 we have extended these libraries, and so in your module if I go now in my DFTB, so this is my studio interface, and if I go in my parameterization, or if I go here, sorry, in the electronic tab I can choose a wide number of libraries, right? And by the way, yeah, so we have added the basic library. We've also added a couple of homemade, that means Axelis made library for organic compounds, simple one, but we also imported some for specific semiconductors and so forth, right? Those are published. You can get, so the CH1, those are the original libraries from Axelis, that one. And if you take one that is, say, from the Bremen Institute, or maybe we go, okay. So you have extended libraries, a lot of compounds, and if, as I said, if you don't have, what do you do? Basically, you're going to use a DMOL 3 to run the calculation on the extra elements that you want to add, right, for the bonding and the angle and so forth. So yeah, and then you can add new element to an existing library, so you don't have to restart from scratch every time, right? In DMOL 3, so there was some time-dependent DFT as well, functionality for optical spectra. So you predict the UV spectra using DMOL, TD-DFT. So that is in the So when you go in your properties, you ask for optics, and that basically gives you the possibility to calculate, to use the TD-DFT and various methods, and you can even predict the polarizability. Be heavy, but you have the resources here to do that. So an example in the pharma industry, for example, is to look at the photodegradation of compounds. So typically they will screen the compounds, and every small molecule that will have possible photoexcitation above, say, 400 nanometers will be possible to degrade with UV light. So then your medicine has to be into a bottle that is darkened, or it's been stored anyway into dark, right? Not exposed to light, otherwise it might degrade. Okay, so you can screen compounds like that using this sort of calculations and have an idea of the risk of photodegradation. We've added a new basis set in DMOL 3, the DNP plus, so the double numerical plus polarization, and that's and plus, so that's a diffuse function. So for those used to the Gaussian terminology, that is a little plus that you have in a basis set. So the DNP is like a 631G star star, and that would be a star star plus, hence the name. So that will be pretty important if you're studying a bit more diffuse electrons, right, like such as an ionic state. So this small molecule here, charged, right, so give you an electron affinity of 0026 eV. Well, the normal basis set got it pretty wrong. PBE again is really the bad kid today. PBE got it wrong, so we correct with this diffuse function. Basically, your electron is really far. If you don't have a diffuse function, you don't have enough space in your electronic description for this extra electron that wants to be really far away, diffuse. So we also improve stability for large calculations, so that if you're running some heavy calculation, we have improved the stability. So that was for the QM. Any question on the demo or CASTEP? No? Fine. So okay, we've seen CASTEP for plane wave calculation for solid state, DMOL 3 for molecular and periodic systems, DFTB plus, that's a new kid in the box, and all the new libraries associated for calculations. Let's move now to the second box in Math Studio on the classical modules. So here we have Newtonian dynamics, description of, and then we use Foresight Plus for MD, Mesosight for say dissipative particle dynamics for soft materials, polymers, and then we have a couple of tools for conformational search. GULP is more for inorganic systems. Then we have Monte Carlo based methods such as Amorphous Cell for building polymer system and formulation, complex formulations, liquids. Thorption for looking at the isotherm predictions, or adsorption site, catalytic site inside the mesoporous materials with adsorption indicator, and blends to look at the energy of mixing and parameters between two polymers or polymers solvents. So Foresight Plus is the main tool we have for molecular dynamics. You get structural properties, radial gyration for polymers, radial distribution functions, so structure factor, you can output X simulated structure factors, diffusion, elastic constant, elastic properties. There is 2 new tasks in MS for Foresight: sharing and confined share. So that allow you to, we'll do that tutorials, to simulate, predict the viscosity of your material. So that was for atomistic simulation. Mesosight makes you move to the next scale, the mesoscale. So here we're going to micrometers, and then we can start to simulate larger systems and also larger lengths, time lengths, right? Like phase separation of chains or surfactants, organization in different phase. So that can be very important. This is used a lot in the consumer packaged good industry that Eugenia mentioned before, in our customers like the Unilever and Procter & Gamble and so forth use this sort of tool to predict the behavior of their formulation of soft materials. For shampoo, toothpaste, washing powder, and so forth. And all those things can be simulated with this sort of models. So in the new functionalities, we have implemented a new automated charge group assignment. So that is very good, because then that allows you to run very fast simulation. You know that the summation method is really what takes most time in your classical simulation, and how you calculate the non-bonded interaction between 1,4, 1,5 and also between different molecules. So you have a possibility now to generate a charge group automatically. So you go in your tools, so say I have this, go modify, charges, charge groups. So if you have a model which comes from the polymer builder or something like that, then you can use the subunits, because then most of the time your monomer would already contain charge group assignment. However, if you don't have any information, and if it's small independent molecule or you just catch it, then you can use this thing here. And what it does here is to assign, so charge groups. So charge groups are small entity, neutral, and they have to be neutral. And then after that, when I do the calculation of my non-bonded interaction, I'm going to have a switching atom, and I'm going to check for the cutoff if the two switching atoms are within the cutoff. If they're not, then I ignore the entire charge group. If the switching atom is within the cutoff of my atom, then I will take into account the entire charge group. So even if I am here and my cutoff cuts my red charge group here, but the switching atom is here and within the cutoff, then I will take this. So if I take this guy, then I also take this guy. What's important here is to avoid to cut dipoles, right? So you always have interaction, non-bonded interaction with neutral groups. So that is very important for the accuracy. But the good thing is that really fasten your calculation overall. So within 4 sites now, you would really want to use the charge group method for electrostatic and van der Waals. The default is Ewald for solids, but that is really heavy. So now I would try to use this summation method now. Another simple tool that was really requested since since the series 2 times is a geometric evolution property, time evolution property. So you can see here in my 2 models, one with some heavy groups, a chlorine substitution, and then I look at the torsional angle variation as a function of time in my molecular dynamics. Boom. So I have a couple of states, right, up and down, so probably here. However, if I add those big chlorine atoms, then now I have a restriction. I cannot flip anymore because of the steric hindrance, right? So sort of things you can do. New task I mentioned, sharing. So possibility to look at the viscosity of your soft materials. You can edit force field, PCFF and CVFF. As before, you could edit also drying, and you have a force field editor. So we have added PCFF and CVFF, and also extended the functional forms. So that is to allow you to generate sort of a new force field. You can also restrict the trajectory data. If you have, say, a very large polymers, here polybutadiene, and then you have some water molecule or some oxygen molecule, and you're only interested in diffusion of your oxygen, and you simulate that for nanoseconds, you might not want to output every single frame, or say every picosecond frame of the entire polymer, because, well, that's just data you don't really need. What you want is the coordinate of those guys. So to save space, basically you're gonna say, well, output only this subset in the trajectory, and you output everything else, say every 100 picoseconds, but the oxygen every picosecond, to have a better statistic for your diffusion, say, right? So you can play like that. And so, yeah, you write a subset of atom more frequently, right? So polymer modeling, yes, as I said, you can also, so here we are moving up the scale, so you have a lot of tools to build the polymers, dendrimers, copolymers, blocks, and so forth, nanostructures. So we have the amorphous cell, the Monte Carlo based builder for building formulation systems. And it can be just a polymer blend, it can be a small molecule added or solvent, and it can be also extremely complex molecule models. So within the mesoscale, we also have in the recent years invested a lot of effort to help people using the interface to build, to sketch, to build real models. So here you start with defining your bit types. That's basically your Avogadro table. You say I got different bits, different mass, and so forth. Then you build your mesomolecule. You give the architecture of the single molecules. Then after you have another step, optional, but you can define region of space. So you say, okay, I have a 1, 2, 3 region, and now I'm going to say, okay, now I have a solvent here, I have my cells here, and I have just a disordered phase in this third box. And then you're going to associate your model, your mesomolecules, to the various spaces. And then you start with an ordered phase. Once you start with an ordered phase, you can go into mesocyte or DPD task or other tools, Mesodyne, and or just coarse-grained molecular dynamics, GROMACS-like, with the Martini force field. So we also have a tool to automate the coarse graining. So if you start with a known monomer units, what do I have here? PET, I suspect, polyethylene terephthalate. Then I can identify monomer units and say, okay, so that those are motion groups in Material Studio. So they define as a subset of subunits. And then that gives me a mesoscale representation, which then I can use my tool to say, okay, now I have a polymer here or surfactant, I have a solvent, and so forth. Right. So in 6.1, we have done also a little bit of effort in the visualization because we had to remove all the Visual Basic parts. So that's really for interesting for the IT really, but the issue we had that Visual Basic would not be supported anymore by Microsoft, so we had to basically change the language that was used in the underlying of the software and replace that by another code. Improve speed for some of the visualization, possibility to add some vectors on. So say here I am looking, I believe, into the dipole of water phase in an electric field. You can also open the containing folders. So in Material Studio, if you want to copy and paste some models from one folder to another, it's a bit of a pain. Well, now you can open the folders as in Microsoft Explorer. So that really will simplify a little bit. So I have here, and then I can go there and opening containing folders, and that will allow me to play in the Explorer and move everything left and right. Material script. Anybody here is using the Perl script of Material Studio? Nobody dares? Is it too complicated? Have you tried? No? You don't need? If everything is in the interface, but if you miss anything from the interface, you have a few options. You can ask on the Axelis community forum if anybody's done that and download the script, very likely. you can try yourself. We can do some tutorials if you want on how to write your own subroutine within MasterStudio. But the best probably is to use a new functionality, which is a connector to the pipeline palette. But now I'm not sure if they don't have pipeline palette, do they? No. Okay, never mind. So, okay. The good thing also, well, we have added also something that was asked by groups, especially in academia or in large simulation groups in companies. It was about sharing script. So you have now a user menu within MathStudio. Well, I know you guys don't use much scripting, but if you were, so you have now this new user, and then you could have your own script. So you can find, I'm sure in the group there's one somewhere that likes scripting. You always have a guy that likes scripting, and he writes the script and he gives them to you. You save them in your library, and then it's funny when I do that. It goes, and then you can just apply a script. You don't even know you don't even have to know what is the script under all these scary Perl lines. You just import the script, put it in your user library, have the right model in view, and then click run. If it's calling from for parameters, then you will be asked in the script at the beginning, usually of the script, some input parameters. So that is one way. You can also have in your library, you could also have a shared library of script. So now you have in a group, you have someone that owns the script, say the original versions, and probably won't let you write anything in there, but it will have a series of scripts in there that you could also call. So that is a shared folder, and everybody call a script from there. We hope one day to have an access directly to an Axelois page where you could call all the scripts that we all write for all those things all the time. And also from the community forum. I don't know, any one of you registered at the Axelois community forum? Come on. This is the place to be. And you have all the talks about the software, the Material Studio stuff, and a lot of script and how to do things and so forth. Okay? Just go there. And they answer all the questions you want. People, us, and some more announcement to the scripting, but that's not much of a concern here today. Also, a big thing, as I mentioned, is the connection to the Axelois Enterprise platform, also known as Pipeline Pilot. So that allows you to submit a protocol directly from Material Studio. What is a protocol? In Pipeline Pilot, possibility to do visual programming where you do a series of tasks very easily. So you can automate calculations, create reports, and integrate with third-party codes. That's important. So Pipeline Pilot allows you to integrate basically any software, Axelois or not Axelois, right? The important point here is that it was developed as a software independent until Axelois bought it. But still, you can integrate, and a lot of tools are made to be called. So for example, within my Pipeline Pilot, and also via, so am I connected here? So that is my Pipeline Pilot personal page where I can run protocols. So for example, games. You know games? Yeah. Right. Games is a QM package that is a freeware, well, new licensing, GNU licenses that you can call. So I have here an integration of the game's code within Pipeline Pilot, and now what I can do is within Material Studio call that protocol and so I need 2 hands here. And then if I execute this thing, sorry, it's very small. Up, water, game, so hip. Then I have execute the games calculations, and I have all the output file from the games calculations. Okay. So that is running games from Material Studio, basically. Right? Which I wouldn't recommend because I think Dmol is much better. But if you want to use any software, then you have to think of if it's open source and you can call the exe file, then that's pretty easy. That's what I've done here. If it's now software from a different vendor, then it might be a bit more tricky to integrate, and you have some licensing issue to respect and so forth as well. But if it's if you can call the exe file, then basically you can do that. So you can integrate third party, you can interact with databases. A lot of our customers have both Sigma Aldrich catalogs or whatever database or chemical or drugs databases, and then they want to screen. So they will use typically this sort of tools to automate when they have a very large number of calculations to run and to automate. So that is typically in the pharma industry. Is it time? Sorry. Is it? Okay. Where are we? So yeah, typically run the same calculation task on a very large number of tools, or to run a series of a very complex task as well. Say you want, so we have an example, say a solubility parameter prediction. Typically within 2 polymers, you will take your polymer builders, sketch a few chains, use amorphous cell to put them together, run a molecular dynamics to equilibrate, run a constant pressure dynamics to equilibrate the density and cohesive energies, and then after that you will do an energy cohesive prediction, and that will give you solubility parameters. You'll do that for each phase and the mixture, and then the difference give you, say, something proportional to the chi parameters. So you have a very large number of tasks that you have within Material Studio. You have to do by hand, by clicking everywhere. The idea here is that you can collect all those tasks in one protocol, say like a script if you want, and just click run, and that will do every task. You just have to say, I want this monomer, that monomer, and a solvent, and off you go. Again, it's saving time and avoiding error as well, because you're doing the same. So if you want your student to just do some good repetition and crack a lot of materials, and then that's the way to go. Oh, that is for Jarek, but it's gone. A lot of new packages, and then the important one is to remove Windows XP support. Good morning. Remove the Windows XP support, but then we obviously didn't speak the same language with your colleagues because you will do the tutorial on Windows XP machines. So somehow Jarek and what's his name, Camille, have managed to make the software work on an unsupported platform. Thanks to them, we will be able to do, bad luck for you, but you're not there for training anyway. You will be able to work on this, and we don't support Windows 8. We don't. Maybe 7 will, but not today. Okay? So, in a nutshell, today this morning we saw from the visualizer interface where you can sketch, build, import any type of models, really, surface, periodic, single molecule. You can have a lot of quantum mechanical based methods such as CASTEP, DMOL, DFTB and so forth. You can run mesoscale simulation for soft materials, morphology prediction, analytical crystallization for the crystal structure prediction, polymorphism and HP morphology, classical simulation for adsorptions, sorptions, molecular dynamics for organics with a lot of force fields that you can edit, gulp for inorganics, and we haven't talked about the statistical method as well. All that integrate within Pipeline Pilot and the MathStudio collection of Pipeline Pilot. On the community side, right, you can go there, and so in this forum, so you have some people posting new script, for example, how to run iterative Boltzmann inversion. Why do we use that? We use that to automatically generate coarse grain parameters for mesoscale simulations. This is a very well-known method used, say, at Michelin in France, in Clermont-Ferrand. They use Material Studio to simulate a very long dynamics of SBR polymers, and they want to look at the elastic constant and the Young moduli and second of elastic properties of those materials and see how they behave as a function of the chemistry and sidechain and so forth. And they have to do that because those are very, very long dynamics. It's better for them to go into the mesoscale, so they will use this sort of script to perform their simulations. We could also provide a script from a reverse mapping. So now you have a nice mesoscale simulation, and you want to have an atomistic description. So now you're going back, or downscale if you want, from micrometer to micrometer. Okay. So you can go up and down on that. Very convenient, because if you have a polymer structure that is very difficult to equilibrate, think of my PET before, that's a plastic, very rigid plastic for plastic bottles, say. You can start like this to amorphous cell, coarse granite, run a long molecular dynamic with mesoscale, which is quite fast, and then back down into your atomistic simulation. Right? Et voilà. So we have published a few years ago a special issue in molecular simulation, where you must publish. So there were about 50 articles, peer-reviewed papers, all about application of Material Studio, and now the excellent industrial applications. So the best papers were published as a book, and the CSC Press edition, where we published a certain number of papers, again on applications of the software in the industry. Questions? Good. So you know all the modules now. Good. Do you use Material Studio? So you missed the survey before.
No, just I'm trying to get some new inspirations for my teaching.
Okay.
To do and because I'm bored of teaching Word and Excel to my students, so I'm thinking about what else I can show them. And we are using the Accelerates Draw.
Okay.
On one of my lectures,
Yeah.
but I have still 9 lectures to run. So it's I'm just looking for inspiration. What else I can show them?
Right. Good. You come to the right place. This is what you have to show them.
Yes.
So
The package is very much used in academia, as you know. Most of our users are actually academics.
Yes, yes.
Various reasons for that. One of them because the interface is so easy to use, right? And all the series of tutorials that you have and the documentation that you have, where students, instead of coming to bother the professor asking all the questions and how do that, why is there Schrödinger equation, you click F1 and you have a professor online, basically, and all the references, you can go to the library and get the same. Okay, so so some tutorials here, and the rest there. and this is 7.0. This is the alpha release of Windows of Material Studio 7. So that's for the end of the year. I'm not supposed to say that. Okay. I didn't. We worked on many different things. We work on making DMOL 3 even a lot faster, because today DMOL 3 is still writing a lot on disk. So what we're doing now is to making sure on camera everything goes in the memory. So DMOL faster. We work a lot on DMOL in the classical simulation as well. Making basically we work a lot right now on making all those server code a lot faster than they currently are for multiprocessor architecture, which really are the norm now. Because think even here of all what you have. Anything you want to see? Any new functionality? Fine. DMOL 3 is good. Please.
I have one question. Which
Sure.
Linux distribution is?
Which? What's that?
Which Linux distribution?
Hmm?
Linux
Yeah.
is recommended for server.
Oh.
Yeah, so we have some specs.
Yes.
You can send them.
So,
The system requirements.
yeah.
On our website.
So there is two questions in one here. That what do we support, right, and recommend it. So
Because yeah, sometimes it would run on a system we haven't tested, but we don't recommend to use it because we have not. So Red Hat Enterprise Linux Server 5.7, 5.8 are you open?
but it doesn't matter, because even if it doesn't work, yeah, I can come in and make it work.
Thank you.
Because you have your own installation of the software.
No.
Okay.
Not the server.
No.
Just the client.
Just the client, yes. So every one of you normally pay a fee to ICM. Yes, you have to pay. You pay a fee to ICM to connect. Then you download the visualizer and all the servers, but just a visualizer, and submit the job here on the supercomputers. We do have teaching licenses. If you talk to her, and she gives you a card and you can buy teaching just for teaching. It's different model, I suppose.
So it's a group of 20 students, and then they can use it at the same time, but it can only be used for teaching, so you cannot publish any papers when you use this license. So, yeah. But they have some teaching licenses as part of the,
Package.
yeah,
So
we need to speak.
we'll talk to you.
Jacek.
Talk to you.
Jacek.
Okay, so no more questions. Mat Studio, everything's clear. You know all the modules: quantum, classicals, analytical and crystallization, statistic. I didn't talk about the QSAR. That's also known. A lot of informatics solutions and a lot of ways to connect. Material Studio in the first stages, when I started at Axelis, was really a black box. You had a few modules and you couldn't connect to anything. You didn't have a scripting. So now we're making sure that the box is really open as possible. Possibility to call script, to call external applications, and import and export data in all sorts of formats. And with a connection to the Pipeline Pilot platform, it's really opened a new world of integration with third-party application, with databases, and connective with all the life science guy. Because Discovery Studio, that my colleague is actually running the training upon today, and gives a talk tomorrow for his Discovery Studio, is actually deployed onto the platform itself. And who knows, maybe Material Studio would do the same. So we use this Axelis Enterprise platform to build all the applications at Axelis.